Hey, what's up, guys? This is Chung here. So, someone suggests me to increase the font a little bit more. So I zoom in this page a little bit more to 150%. So let me know what you guys think about this font. I think this should be big enough, right, for you guys to see it. Okay, cool. Let me know. Okay, so let's take a look at like one of this week's bi-weekly contest problem, which is the 1604. Alert using same key card three or more times in a 1 hour period. All right, so hmm, I'm not sure why a lot of people downvoted this problem. I mean, I think it's okay problem, right? I mean, okay, so LeetCode company workers use keycards to unlock office doors. Each time a worker uses their keycard, the security system saves the worker's name and the time when it was used. So the system emits an alert if any workers use the same card key three or more times in the 1 hour period. Okay, basically, you're given like two lists. Basically, the first one is the name of the person, and second one is the time, right? The time that this person used this key card, and it just asks you to find the persons who has used this key card more than three times in an hour. Okay, mm, you know, so for this problem, so it's obvious, right? We need to group those punch times, right, by the group by the persons, and then we just need to sort them. We just need to sort those times, uh, and then after that, we just need to use a sliding window, right? So the sliding window is going to be an hour size sliding windows, and we just check if there's any at any moment if there's any more than three times inside that sliding window. If there is, we simply add it to the final result. Okay, and of course, in the end, it also asks you to return the uh, sort names in ascending order alphabetically. This is just it's just like a sort in the end. Okay, and I think one of the things we might need to be careful, not be careful, we just need to be aware is that uh, the times given in the format of a string here, like hour and minute. So when we use the sliding windows, we need to find a range of those times, but those are strings, and to add 1 hour on top of the current on the current one. Basically, for example, if we stick with the strings format, let's say if the 12:00, if we want to look back for 1 hour, it's going to be a 11:00. Okay, otherwise it's going to be a what? Some other format. Let's say if there's like 10:00 and we're going to be 9:00. Basically, the string manipulation in terms of in times will be kind of annoying. So there's a simple way. We just need to convert like this string format to an integer time. Basically, we just get the hours, right? So we have a hours times 60 plus the minute. Basically, we just convert everything into an integer of a minute. So that will be easier for us to compare. Cool. I think that's it. Let me try to code these things here. So basically, first we need the end here. We have a length of the key name. We can use either of the list here, and then we just need to like a times, right? For we just need the like dictionary basically to store the times for each person's, and then for like I in range n here, okay, we have a name, right? The key name dot I, and then we have a time goes the key time, okay, and that's that. And now we just need to convert this time into its integer number. How do we do it? We simply do we split these things uh, in by the colon, right? and then we have a hour int equals to the t0, okay, and then we have a minute int t1, okay, right? Now we have the integer type of the hours and the minutes, so now we can store those things here, store the time for this person, basically this times this person, okay, name, right? We append by the what? The age times 60, right? Plus the minute. Okay. So now we have this, we have groups all the times for each persons. Now we just need to loop through the persons, each person inside the times dictionary. Okay, and then we have a time list, right? Let's say we have time list here, so it's going to be a times dot name, and then like I said, since we're going to sort it, so I'll just do a sorted here, like based on that, based on the times here. Okay, and then for the sliding windows, I'm going to use a queue here to keep track of our current the punch times inside the current hours. So I'm going to use a DQ, right? Since we will be popping from the tail later on. So now, and we have for each time in the in the sorted time list now, right? And we add this thing, right? So for the sliding windows, we add these things to the end of the queue here, and then we'll try to pop all those invalid times. So basically, this is how we do while the time minus, right? The current time minus the last one in the queue is greater than what? Than the than 60. Basically, then 60 minutes. Remember, since we have already converted everything into the minutes format, so that's why we can simply check. Basically, if the current time and the last element, the difference is greater than 60, then we know, okay, so we need to pop that things. We just do a pop left. We do it until the last one is within the 60 range. Then we check basically if the length of the current queue, right, is equal or greater than 3. Then we know, okay, so this person needs to be alerted, which means we need to add this person to our final answers, okay, and we can simply break the for loop here because we there's no need to continue for the current person, okay. So yeah, and I think that's it. And in the end, we simply return a sorted version of the answer here, since we need to sort it in the alphabetically way, right? So we do a sorted answer. Cool. I'm going to run this code. So we have Daniel here, and let me try to submit it. Yeah, cool. So it's accepted. I mean, cool. And oh yeah, and how about the time and the space complexity, right? So for the time complexity, we have like n here. So we have a on here, right? That's a on, and then we have this is like the number of the different persons here, right? So it doesn't. Do we have how many persons do we have here? Yeah, on here, and here for each of the persons will be sort. Basically, we'll sort the uh, uh, the times for each of its person. I think the worst case scenario is if everything is for the same persons, right? Basically, we're gonna have like one name here, and then we'll sort this thing. So here, the worst case scenario is that we're gonna have like a n log n here, right? N log n, and then this is like a for loop here, right? This is n log n plus n here. Yeah, because here we are only each of the time will only be added once here. So and then we have a in the end we have a sorted here. Okay, so basically the worst case scenario for this one, the time complexity is n log n. in the case every all the times are for the same persons. That's why the worst case is we're gonna sort all the times for this person, which is n log n. Okay, and and space complexity, I think space we have times here, right? So for the times, yeah. So for the time for the sorry for the space complexity is O of n. So this is the time here, and space is O of n. Basically, we'll be storing each number each time inside our times dictionary. That's the O of n here. Uh, yeah, cool. I think that's it for this problem. Yeah. Okay, thank you so much for watching this video, guys. Stay tuned. See you guys soon. Bye bye.